Hi, good morning to everyone. This is Chitra from IT department, S.A.E. Engineering College. Okay, now we are taking the syllabus is distance vector routing and link state routing protocol in computer networks. First, what is the difference between distance vector routing and link state routing? So distance vector routing means it's nothing but we find the minimum distance between two nodes. Okay, link state routing means it's nothing but we find the shortest path between source and destination. Okay, so in this distance vector routing we no need to the minimum, that is the neighboring node vertex. Okay, the first one, this is the distance vector routing, the least cost route between any two nodes in the route between the minimum distance. Okay, this is the example. We have that one initialization of that. So in this initialization, first one we need the table, that is the root table. Next one, each node knows the cost of other nodes. Okay, so how to find that cost? Each node knows how to reach any other node and their cost. This is the second one. Third one, at the beginning each node know the cost itself, that is the self cost and its immediate neighbor cost. Okay, next one, I should each node send a message to the immediate neighbors and find the distance between itself and this neighbor node. That is a distance between itself means it's a self node distance we need, at the same time neighboring node distance we need. Final one, the distance of any entry that is not neighbor is marked as infinitive, that is the unreachable. Okay, so this is the first one. This is the example for distance routing. Here in this example, this is the diagram. Here it's having 5 nodes is there. Okay, this is the A, B, C, D, E. This circle shape is called a node. This is the path. Okay, that is the A to B. This is the cost. 5 is the cost, and C to B is the 4 is the cost. So what is the neighboring node means? This is the A is the root node. Okay, so what is the immediate neighbor means? A to B connectivity is the, A to C is connectivity is the, A to D is the connectivity is the. So A neighboring nodes are B, C and D. So what is that the unreachable node? E. Okay, so in this point already we see that the point, the distance of any entry that is not neighbor is marked as infinitive. So in this example, A we cannot reach to E. Okay, so here the cost is note down the infinitive. So first one, A table. So in this one, A we start from A, no self node is there. Okay, so the cost is 0. So what is the next node? No next node is there. So just we mark as the dash. Next, A to B, what is the cost is 5. A to C cost is 2. A to D cost is 3. Okay, these are the neighboring nodes. A to E we cannot unreachable. So A to E we mentioned that infinitive. This is the A table. Similar to the B table, we start from B. Okay, so A we reach to B, cost is 5. B it's not self node, so B is 0 because this is the B table, so no self loop is there, so B it's assigned 0 cost. C, B to C cost is 4. B to D we cannot reach because this is not neighboring node, so we put in this infinitive. B to E we assign 3. Okay, this is the B table. Similarly we write that the C table, D table and E table. So here we check that the D table we having only neighbor is A only is there, so D to A cost is 3. We cannot reach B, C and E, so this is the infinitive. This is the D node, so D self loop is 0. Okay, so this is the initialization of table, that is the routing table. Next one, we sharing the table. Okay, so what is the process for sharing means? We need to find the B to E, that is in this D table B, C, E it's put infinitive. Okay, so we need the cost of B, C and E. That's the process we using for the sharing. So what is the idea to share? So in this one, idea is to share the information between the neighbor node. First one, the node A, in this example, node A does not know the distance about E. Okay, but node C no. Here he does not know the distance in for E because E is not neighboring for A. But C node is know that the distance for E. Okay. Now A and A node and C node we share the cost. Okay, so this is the meaning for the sharing. On the other hand, node C does not know how to reach D, but node A does. Similarly, node C cannot reach D because this is the not neighboring node for C, but A it can reach D, so it's know that. So now A and C share the cost. Okay, so this is the sharing process. In this sharing, so this is one. First you write that the A, okay, but now we share that the A and C. So first you write that the A old table, okay. So there's a node is A, B, C, D, E and 0, 5, 2, 3, infinity. This is the old table only. Already we write in this A node, okay, 0, 5, 2, 3 and infinity. C table is 2, 4, 0, infinity and 4. That only we write here 2, 4, 0, infinity and 4. So this is the A old table, this is the C old table. Now we sharing we apply. Okay, so compare A and C, we modify the A table. Okay, so what is the modification of A table means? Now A to C. Okay, in this one we using for A to C. Okay, so in this diagram you check that the same diagram A to C means we using A to A self node. Generally A self node is not there, so we put in this cost is 0, but using C, A to C, okay, A to C, again C to A we can use, that is the A to A via C is A to C and C to A. So 2 plus 2 cost is 4. Okay, what is the next node is C. Next one B, A to B. Okay, so A to C, C to B, because we using for through the C node only. So A to C, C to B. A to C is 2, C to B is 4. So 2 plus 4 is 6. Next one C node. Okay, C node is A to C directly is the, that is the 2. A to D. Okay, so A to D. So that is the A to C, C to D it's not the. So that is we put in infinity only. Okay. Next one E, A to C, C to E. So 2 plus 4, 6. So in this in this table we using the modified A table, but through C node only. Okay, that only we write. A means A to A, that is A to C, C to A. B means A to B, B to C. Okay, next one C means that is the self node. D means A to D, via C it's not applicable, so that only we put infinity. Okay, similarly E is A to C, C to E. Okay, so now you compare the modified table and old table, because we find out only the A table. Okay, so in this modified table A cost is 4, old table A cost is 0. So what is your new table? We need, what is the purpose of distance vector routing? We find out the distance, we find out the minimum distance. Okay, so here 4, here 0, so we using the 0 only. Okay, next one B. Okay, so here in this modified table B cost is 6, here old table B cost is 5, so we need that minimum distance, so we using only B to 5. Next C is 2, here also C is 2, so we using the old table cost C is 2. Next one D, 3 and infinity, so 3 is at the minimum, so we using 3. Next one here 6, here infinity, so here only we using E. Okay, E, the cost is 6. So what is the next hop? So how to reach the A to C? We reach through E only. Okay, so that is the A to E we reach through C only. That is the next node is C. Okay, so in this A it's having B, C, D or the neighboring node, but E we cannot reach. But in this A to reach E through C, that is the A to C and C to E, that is 2 plus 4 is 6. Okay, this is the new table for A. So each and every table you find out the B, C, D, E and new table. Okay, so this is the example. So in this one, how to understand this, that is the distance vector routing, how to sharing we can use means it's having 3 key points is the one is the sharing knowledge about the entire AS, that is the entire node. Okay, second one sharing only with immediate neighbors only. Okay, first step we share the cost in immediate neighbor, second one we using the sharing knowledge about the entire AS, last one, okay, both are we using the, and third one sharing at regular intervals, that is the regular interval means same at fixed interval time. For example, we fix every 30 seconds or every 1 minute and so on. Okay, so this is the key points to share the cost between the nodes. Okay, so this is the final distance vector routing table. So this is the diagram. Already we know that. So we know that how to find that new table for A. So that is the process. In this one we find out the new table for A. Similarly we find out the remaining table. So now we take the B table. Okay, so in this B table, A to B cost is 5. B is the B table, so B no self loop 0. B to C, already we know that the cost is 4. B to D. Okay, so B to D we through A only. We can reach only one node in this intermediate node. That is B to D we can reach B to A to D. One method. Second method, B to C, C to A and A to D. But in this B to D we can use two nodes A and C. That is not applicable. We can reach one node to another node. Intermediate is only one node. So B to D we can reach B to A to D. Okay, so that only here we write the immediate next node is intermediate node is A. So what is the cost? B to A is 5, A to D is 3. So 3 plus 5 is 8. Okay, next one similar C table. So in this C table, C to A is 2, you know, and C to B is 4. C to C no self node, so 0. C to D again we reach C to A to D. So 2 plus 3 5. What is the intermediate node is A. So next one E, C to E is 4. Okay, this is the new table. Next one D, similarly D. So D to A is 3 and D to B we can reach D to A to B. Okay, so that is the next node is the intermediate node is A. So what is the cost? 3 plus 5 is 8. Okay, next one C. Similarly intermediate A, D to A to C. So 3 plus 2 5. So D is the self node. So the cost is 0. So next one is the E, D to E. How to reach? D to A. Okay, so next one we reach D to A. Here we so in this D table we can reach D to A to E. Okay, so that is using the cost is 9. Okay, next one final one is the E table. So in this E table you using the E to A is through C, intermediate node is C. E to C is 4 plus 2 6. E to B already is there 3. E to C direct neighbor node 4. E to D we using for C only. So E to C is 4 plus 2 6 plus 3 9. So D to C is intermediate node is 6 C and cost is 9. E to E, that is the self node, no cost is 0. Okay, so this is the final distance vector routing node. So what is the distance vector routing? So in this distance vector routing we find the minimum distance between the nodes. Okay, so first we check that the immediate neighbor node. Suppose we can't use the immediate neighbor node is not there, means we sharing the cost between the immediate neighbor node. Okay, so this is the distance vector routing table. Okay, this is the concept. Next concept is link state routing. So what is the link state routing means? Link state routing is a technique in this one where each router exchange the information about its neighboring routers with every other router in the network. Okay, so distance vector routing, just we find the cost. Okay, we find the minimum cost between the nodes. But here link state routing means in this entire router network we find out the minimum shortest path. Okay, that is we find the shortest path from source to destination. Okay, so now we here also we using the 3 key points. First one, knowledge about the neighbor node. Okay, second one is the flooding. So in this flooding concept we using in link state routing only. So what is mean the flooding means? Flooding is the each router send the information to every other router on the internetwork except neighbor. That is called flooding. Okay, information sharing means it's nothing but we sharing the information between the node to immediate neighbor node. Okay, so this is the link state routing. So in this link state routing, we have the two phases. Is the first phase is the initial phase, second phase is the final state phase. Initial state phase means is nothing but each node know the cost of its neighbor node only. Final means is nothing but each node know the entire graph, that is the source to destination, we know that. Okay, so in this one we using that the formula is d of v equal to minimum d of v comma d of w plus C of W comma V. So in this C of W comma V means is nothing but C of I comma J, that is the cost from node I to J. Okay, we find that the node I and J or nodes are not directly linked, means it's assigned the cost is infinitive. Second one, D of V means it's not, it's a path from source code to destination, that is the D of V. P of V means it's nothing but previous node. N means total number of nodes available in the every network, okay, in the entire network. Okay, so this is the diagram for link state routing. So in this link state routing, in this figure, source vertex is A. Okay, so the first one, first step, initialization step. So every step we need this diagram, just we see the diagram. In this one, A is a source node, A is directly connected to B, A to D and A to C. That is the first initialization step. The currently know the least cost path from A to directly attached neighbor node is B, C and D. Okay, so we cannot find the cost is E and F because A is not directly connected to E and F. So what is the cost? First node is A. Second one, here you write, this is the node. Okay, this is the source node. You are right in this table. First you write that the step, how many steps is the. Second you write that the node is a source node. What is the next least cost node and next least cost node and so on. Next one, D of B comma P of B, because A is the source. Next one, remaining nodes B, C, D, E, F. You write D of B comma P of B. Similarly C, D, E and F. So D means is nothing but that is the cost. Okay, next one, P means is the what is the previous node connected to. Here first one you find that the B node. Okay, so A to B cost is 2. So what is the root node? It's a A only. Okay, so next one, A to C cost is 5 comma what is the previous node? A to C connected means the previous node is A only. Here A to D cost is 1. What is the previous node? A only. A to E and A to F not directly path is the, so we write infinitive. This is the initialization step. Second one, we know that which is the least cost. Okay, here we find the B, C and D only. We know that the cost is 251. So which is the least cost? D is the least cost. So second step we start from D only. Okay, here in the second table, okay, in the second step we observe vertex D contains the least cost path in first step. So now we find out the cost. Okay, so again you start from source vertex only, A to B and A to C, next one A to E and A to F. But in this D is the here the root node. Okay, so here we write the vertex is B. Okay, A to B you find out. So B is the vertex node and W is, so what is the root node now? D is the root node. So D is the root node. So the formula is D of V equal to minimum D of V. What is the D of V? D of B equal to minimum D of B comma D of W means D plus C of D comma B. So already we find out D of B, D of D value. So D of B in this previous table you just know the numbers. D of B is 2 and D of D is 1. So here we using D of B is 2, D of D is 1 plus C of D to B. D to B, what is the number? D to B cost is 2. Here you write the cost. So 2 comma 3. So the formula is minimum. So minimum of 2 comma 3 means the minimum value is 2. Okay. Similarly you find A to C. So A to C you find C is the V node and W is the D, because root node, that is the W means what is the root node now, and V means So which node to which node? Okay. So in this A to C you find means that is the C is the V. Similarly, you find minimum of D of C comma D of D plus C of D comma C. D of C we know that the 5 from the previous node, and D of D we know that the 1, and C to D to C is 3. So 3 plus 1 4. So 5 comma 4 means minimum value is 4. Okay. Similarly, A to B we find out, A to C we find out, D is the root node. Now you find out E, because D is the intermediate node. Already we find out that the D is the shortest path. So A to E we using the intermediate D. Okay. So V is E node and W is the D node. Similarly, you find minimum of infinitive comma 2, so that the minimum node is 2. We cannot find F because A to F it's not directly connected, and now that the root node is D, D also is not directly connected. Okay, D is directly connected to E, so that only we find the E, but D is not directly connected to F. Okay, so first two line already we write that the first initialization step. Second step, A, D is the second root node. So A comma D. Okay, A and D. So 2 comma A. What is the here? We check minimum value is 2, and next one A to C minimum value is 4. Okay, already first step minimum value of C is 5 comma A. Now the minimum value is 4. You compare the previous value. Previous value is greater than the second value. So second root node you check that it's a greater value means we use that second one, otherwise we using the previous value itself. Okay, so you compare here 5 comma A, here we using the minimum value 4, so we keep it in 4 only. Next one, D is the root node, so next one E. Now we find out 2 comma D. Okay, so that is the path is we using the previous node is D, and D to F direct link is not there, so infinitive. Similarly, in this table, now this table 2, 4, 2. So which is the minimum value? 2 is the minimum value. Okay. So first node also 2 comma A first step, second step also 2 comma A. So now we using this that node is 2 in E. Okay. So here in this third one, E and B have both the least cost path in step 2. Let's consider E vertex. Okay. Already I told why we select E vertex. Okay. So in this least cost is E. Again you stop. Now you assign the E as a root node. Through you find out A to B, and A to D is already completed, so no need to find out D, and A to C, E is a root node, so and A to F through E. Okay, first is A to B. So A to B we find out that the V is equal to B. Now the W value is E. Okay, this is the root now. So we find out that the minimum value is 2. Next A to C, similarly we find out minimum value is 3, and next one you find out A to F intermediate through E. So A to F we can find the minimum value is 4. So now that the table again you modify the third line A, D and E. E is the root node. Now we assign. So first one you find out 2 comma, same minimum value is 2, so 2 comma A. Next one you check, C is A to C is minimum value is 3. The first step C is 5, next step is 4. Now we see that there's 3. So this is the minimum value, so we using the 3 and E. And next one D already used, so don't write. And E is now you said the root node is E, so no need to write. And next one is we find that the F. Okay, so what is the value? 4. Okay, 4 comma E. Okay, so in this value which is the minimum value, 2 is the minimum value. So now we using the B. Okay, so now we using the B only. So that is the B vertex as the least cost path in step 3. So again we find out A to C. Now because B is at the least cost, so A to C, D already completed, E completed, only A to F. So now we can find out only 2 steps, A to C and A to F. Same formula we using. A to C we find the minimum value is 3, and A to F we find the minimum value is 4. So we write that the table A, D, E, B. Okay. So in this one B, now we using that. And next one C is 3 comma E, same value, because here C is at the 3. Okay. So we write that the same value. Next 4 also the same value. In this previous one we find that the minimum value is 4, again we using that the 4 comma e only. Okay, so the last step, so again you check 3 comma 4 which is the minimum value 3, again we using that c. Okay, a d e b c, again we find out only f only, that is at the a to f. So what is the value? Same minimum value 4. Okay, so that's all that your table is completed. So this is the final table. So each and every step we find out source to destination least cost we using some intermediate node. Okay, so this is the link state routing. So what is the disadvantage for link state routing? So very important. Link state routing, it's created the heavy traffic. That only we told that flooding concept using in link state routing. Heavy traffic is created the link state routing due to flooding concept. Okay, each and every time we find out the least shortest path method to source to destination, that is the heavy traffic. Okay, so this is the link state routing problem. In this one, first one is the distance vector routing problem. It's called as Bellman-Ford algorithm. Link state routing path is called as the Dijkstra algorithm. Okay, so that is the questions. In this one diagram is given. Okay, in your gate questions diagram is given. So this is mentioned that it's a link state routing or distance vector routing. Distance vector routing means just to find out the nearest neighboring node only. Okay, here it's given router C. We using the router. Okay, router is C. From B is given some values and D is given some values and E is given some values. So we having the 3 table only, B table, D table and E table. Okay, because here is given B table, D table, E table. So totally how many nodes we having? 6 nodes is there. So we write A, B, C, D, E, F. Okay, each and every table. So first one B table. So in this B table you write BC because this is the router. BC, DC and EC. So in this value also given BDE or 635. So BC equal to 6 and DC equal to 3, EC equal to 5. Okay, in these things all the things are given in your question. So now what we find out means what is the C new routing table. Okay, here the table is given, that is the table is B, D and E. Now we find out the C routing table for the new routing table. So first find out that the node is A to F. So what is the cost? You find that the cost for A. Okay, so in this A already is there 5 in B table. So now you check that 5 plus 6 is 11. So here A in D table 16. So 16 plus 3 is 19. Here A table is 7. 7 plus 5 is 12. So what is the minimum cost? 11 is the minimum cost we using in next hop is B. Okay. Similarly you find out every node. So B means 0 plus 6 6 and 3 plus 12 15. 6 plus 3 is 11. So we using that the minimum cost is 6. So B to B is 6. Next one C means C is your router. So the no cost 0 and next stop C only. D again you find out. Here you check D 12. Here 0. Here 9. So 0 means this is the least cost, so 3. Okay, D to D is 3. Next one E means 0 is the, so this is the least cost, so 5. F means you check here 2 plus 6 8, 10 plus 3 13, 4 plus 5 9. So this is the least cost is B, so this is 1. Okay, so you find that the minimum table in this method only. The table is given and your router also it's given, just you find the table. Okay. Second question, it's nothing but it's simple. Distance vector routing algorithm is a dynamic routing method only. So the routing table in distance vector routing algorithm are updated what? It's automatically it can update or server or by exchanging the information with neighbor node with backup database. Already you know that the distance vector routing we using for neighboring node only. So option C is correct. Third questions, distance vector routing as optimal cost finally converges to estimate cost after series of message exchange, or estimated cost finally converges to optimal cost, or estimated cost will never converges to optimal cost, or none of the above. So in this one, first you know that the estimated cost, finally that estimated cost converges to optimal cost after series of message exchange. That is at the distance vector routing. Okay, last one, the two popular algorithm, distance vector and link state routing algorithm. Which of the following is true? First statement, count to infinitive is a problem only with DV and not LS routing. Okay, it's a wrong. So in this one, that is first one is the it's a true. Count to infinitive is a problem only distance vector routing method but not link state routing method. So in this link state routing method we didn't use any infinitive is there. In this infinitive we using only distance vector routing. Okay, it's correct. So distance vector routing, neighboring node means we know the cost, otherwise it's not neighboring node means we using the infinitive. Okay, so that is the first statement is true. Second statement, link state routing, the shortest path algorithm run only at one node. It's a wrong. Link state routing we can reach every node. Okay, source to destination we using. Third one, distance vector, the shortest path algorithm is run only at one node. Also wrong. Distance vector routing node we using a routing algorithm we using to find out the minimum distance between neighboring node. Okay, so that also the wrong. Last one, distance vector routing requires less number of network messages than link state. Yes, is correct, because distance vector routing we find the minimum distance between neighboring node only, but link state routing every time you find from source to destination. So distance vector is less number of network messages than link state. Okay, so in this option D, S1, that is the first statement and last statement only true. In this second statement and third statement is false. Okay, thank you. Continue on the next gate video.